Good evening, sixth grade math. We are going to go over the review for your first test for the Unit 1 mid-module assessment. So here is the answers to this. So number one says the most common women's shoe size in the U.S. is reported to be an 8.5. A shoe store uses a table like the one below to decide how many pairs of 8.5 shoes to buy when it places a shoe order from the shoe manufacturers. So we have our total number of shoes and then the numbers of pairs of 8.5 that they're ordering. So it says, what is the ratio of the number of pairs of 8.5 shoes the store orders to the total number of pairs of shoes being ordered? So the smallest information we have is 50 shoes to 8 pairs of 8.5. So to try and get the most basic of that, we can divide both of these by 2. This ends up being 25 to 4. I cannot break those down any further, so we have a 25 to 4 ratio. So that means that for every 25 shoes being ordered, 4 of those shoes are going to be 8.5. So then here it says plot the values from the table on a coordinate plane, label the axis, then use the graph to find the number of pairs of 8.5 shoes the store orders for a total order of 125 pairs of shoes. So here our number of shoes go up to 200 and the number of pairs being ordered goes up to 32. So on this side, you can label them in 25 increments, 25, 50, 75, 100, 125, 150, 175, 200, 225. This makes sure that you are using all of these 50 increments and as well as hitting this 125 increment. So now we have to get to 32. I'm going to label these with 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. So again, I have all of the values here that are here. You could do this differently. You could have done these in 5s. Since these are 4s, 4s make sense here. And since these are in 50s, you could have done these in 50s as well. But this way we're ensuring that we're hitting that 125. Then we're also going to label this. So this is total shoes. And this is pairs of 8.5. Then I'm going to label this with shoe orders. So now we're going to use this data and put it on here. So the first point we have is 850. So I'm going to put that dot right there. The next dot is 16,100. So I'm going to come over to 16, go up to 100. That one's done. Our next ordered pair is 24,150. Right there. And the last one is 32 to 200. If your graph is switched, that is okay. So if you have your total shoes here and your pairs here, that is okay. They can be switched. We also have our 25 to 4. So 4, 25. Now I'm going to connect these. Bear with me. So there's the line connecting it, going on infinitely. So now it wants to know approximately how many pairs we're ordering for 125 shoes, total shoes. So here's 125. Our point here comes down to 20. So 20 8.5 size shoes. For 125 total shoes. And we can also figure that out too using our information here. So if I take my 25 to 4, figuring out how many times I have to multiply this to get to 125, which is 5. Multiply both of these by 5. 125 to 20. That again just verifies the total number of shoes I'm buying if my total order is 125. And we get the same answer as we should. All right, flipping over to the back. Well College in Aurora, New York has previously been an all-girls college, and in 2005 the college began to allow boys to enroll. By 2012 the ratio of boys to girls was 3 to 7. So I have boys to girls as a 3 to 7 ratio. If there were 200 more girls than boys in 2012, how many boys were enrolled in that year? Use a table, graph, or tape diagram to justify your answer. Use a separate sheet graph paper if you need to do so. So, if we're going to make a, let's do a table. So I have boys and I have girls. Sorry, it's hard to do this one-handed. So our basic ratio is 3 to 7, and then let's add a total column here too. So that is 10. So I need to have, actually no, let's change that to difference. So that gives us a difference of 4. We're looking for a difference of 200. So let's multiply each of these values times 10. So that's going to give me a value of 30 and 70, which gives me a difference of 40. That's not what I need. I need a difference of 200. So I'm going to multiply these again times, let's double it. So I'm going to do 60 and 140. That gives me a difference of 80. Still not enough. Let's multiply this again times 2. So I'm going to do 120 and 280. This gives me a difference of 160. We're getting closer. All right, so let's add. So if we notice we have a difference of 40 here and a difference of 160 here. If I add those together, I'm going to get 200. So I'm going to add 30 to this one, which gives me 150, and 70 to this one, which gives me 350, which then in turn gives me a difference of 200. So there are 150 boys enrolled and 350 girls enrolled. And it's asking how many boys. So our answer is 150 boys. All right, last question. Most television shows use 13 minutes of every hour for commercials, leaving the remaining 47 minutes for the actual show. One popular television show wants to change the ratio of commercial time to show time to be 3 to 7. Create 2 ratio tables, one for the normal ratio of commercials to programming and another proposed ratio of commercials to programming. Use the ratio tables to make a statement about which ratio would mean fewer commercials for viewers watching 2 hours of television. So here we're going to start with the current, or normal as it's stated, normal programming. So our commercials and our live TV or programming is going to be 1. So it says our ratio is 13 minutes to 47 minutes. Both of these values are prime. I cannot break them down any further. And then I'm going to add a total column as well. just to keep us making sure that we are looking at the information that we need. So now I'm going to double this for our next value. So that's going to be 26, and 47 plus 47 is 94. This ends up being 120 minutes or 2 hours. I can continue that on. That's going to be 39, and 94 plus 47 is 11, 141. This is going to be 180 hours. And I can continue this on, however, we're just looking at 2 hours, so I really could have stopped there. Now we're going to look at the proposed programming. So we have our commercials, our live TV, and then we still need to figure out those totals. You don't have to add the totals, but it's just going to help us to make sure that we're getting to that 2 hour mark. So now they're proposing that we have a 3:7 ratio, which for every 3 minutes, for every 10 minutes that we're watching TV, 3 minutes of those are commercial, 7 minutes are live TV. So I can increase this by adding 3 and adding 7, but that's going to take us quite a bit of time to get to this 2 hours or 120 minutes. So I'm going to double that. I'm going to give that a 12. This becomes 28. This is 40 minutes. I still need to keep going. So let's double this again. So I have 24, 56. This is 0, 10, 80 minutes. Still need to get up to 120. So I'm actually going to add these two values together. You can extend this. You can do this however you want. This is just how I'm doing it for this example. But it doesn't really matter as long as you figure out how to get up to that 120. So I'm going to add these two values, 36, 28, and 56 is 84, 6, 10, 8, 120. Oops. So I have 120 minutes total. So now I'm going to compare this information with this information. So coming back to our question, use the ratio tables to make a statement about which ratio would mean fewer commercials for viewers watching 2 hours. Well, if we're looking at the minutes, our normal programming has 26 minutes and our proposed has 36. So essentially you just have to explain that the normal programming gives the viewers the least amount of current commercials with 26 total minutes for 2 hours versus the proposed programming, which gives viewers 36 minutes out of those 2 hours total. So that's just something you would explain. Write that in a sentence, write that in a couple of sentences, but this is the math behind it. Please feel free to reach out if you have any questions. I hope this was helpful. Bring your reviews back tomorrow so that you can use them on the test. Have a great night.